Welcome to Perimeter and Area Lesson, Podcast 1. Right, so this is in your notes, and on this page we're just going to review the formulas for perimeter. Come on, pen. There we go. So perimeter is the measure of the outside. And area is the measure of the inside. Add this to your notes. Right, so on this page here, we're just going to review some formulas. And if we find some basic formulas, we can find the area and perimeter pretty much of any two-dimensional figure we want. We're going to be focusing on finding area and perimeter on the coordinate plane. But before we do that, I thought it was important for us to just review how do you find area and perimeter at all. And so B here, when we see B, well, first of all, by the way, we're looking at rectangles and squares. And essentially, finding the perimeter or area of a rectangle or a square is pretty similar. And so let's talk about the rectangle first. Right? So sometimes you'll see something called, so it'll be labeled B or H. B stands for the base, and H stands for the height. My A looks a little funny there. Base and height. And essentially those are just two different dimensions of our rectangle. And it really doesn't matter whose base and whose height, so long as one measure is base and a different measure is height. Right? I wouldn't pick the side directly across from the base here because this length and this length are exactly the same. We want the two different lengths, right? So base and height. So to find for the rectangle, to find the perimeter, notice that these two are the same and these two are the same. So I could say that the perimeter is this B here plus the other B, which is exactly the same, and one H plus the other H. Or I could just say, well, there's two of them. 2 times the base plus 2 times the height. Sometimes it's written 2 times the length and 2 times the width. And guess what? That's the same measurement. Whether I call it base and height or length and width, I'm still talking about two different measure sides. We'll call it base and height because it comes up in other figures, right? So I'm just going to call it base and height. The area, right? To find the area, to find the amount of stuff on the inside, I just have to take the product of the two different measures. So the area of the rectangle is going to be the length of the base times the height of the figure. And that's going to give us the area for a rectangle. A square is really basically the same. The only difference is, instead of having two different measurements, they're all exactly the same. Right? So instead of writing 2 times the base plus 2 times the height, sometimes, and having two of the exact same measurements, sometimes we just call that an S for the side, because all 4 sides are exactly the same. So to find the perimeter, we can just add up the 4 sides, or instead of having to add them all up, since they're all exactly the same, we could just say it's 4 times the length of the side. For the area, it's basically the same measurement, base times the same calculations as the rectangle, but since the two different sides, this one here and this one here, are exactly the same, instead of saying base times height, we just say side times side, which is the same as saying side squared, right? So basically you're doing the exact same calculations, it's just since they're all exactly the same measurement, we don't differentiate between one side and the other. And so we just multiply add all 4 sides, or just multiply one side by 4 to get the perimeter, and you just multiply one side by itself, or square the side. It's a square, you square the side to get the area. Okay? So that's how we find the area of a rectangle or a square. Pretty simple, right? The triangle is almost the same. if I have a rectangle here, any old rectangle, I'll just grab a rectangle tool. And you don't have to write this down, but I just want to show you one little thing. So here I have a rectangle, and I divide my rectangle in half. I get two triangles, right? I get one triangle here and another triangle there. So to find the area of a triangle, let's talk about area first. To find the area of a triangle, instead of base times height, and base is still, B is still base, and H is still height. To find the area, I just have to take half of the same formula I used for the rectangle. So instead of base times height, it's 1/2 base times height. Base and height. And actually in this particular triangle, the height is not one of the sides. It's that right there. Right? It's this line. Let me put it in a color that you can maybe see. Let's do purple, because I haven't used any purple. That right there, that purple line I just drew in, that's the height. So we'll talk about why it's that line and not one of the sides in a moment. But you can see now why I used base and height for the rectangle, because nobody ever calls it length and width for the triangle. So it makes a little more sense if I say base and height on the rectangle, then triangle makes more sense. All right, so, and you can see I can get two triangles out of one rectangle. So if I take the formula for the area of a rectangle and multiply it by half, I have the formula for the area of a triangle. The perimeter, well, it's exactly the same as the rectangle and the square. Let's just call this, so we already said this was base and this is height. So let's just call this side here B. Right, that's going to be B. We haven't named the other sides anything. So I'm going to call this side A, and I'm going to call this side C. So to find the perimeter, I just have to add up the sides. I don't have any way to simplify that. So like for the rectangle, we had 2 times the base and 2 times the height. I may very well have 3 different measurements for the triangle. So we'll just say you add up the 3 sides, and that's all there is to it. All right, so that was it for the for the triangle. Let's move on to the circle. All right, so important values in the circle. All right, we have the radius. As a matter of fact, the only value we need to calculate the perimeter in a circle, we call the perimeter the circumference. But circumference of a circle has the exact same meaning as perimeter for the triangle or the square or the rectangle. You're just measuring the outside part. Right? All we need is the radius. For pi here, we are not going to simplify that. We're going to keep it in terms of pi. Now, quite honestly, we're not going to find the area of a lot of circles in this particular lesson. We're going to be dealing a lot more with polygons than we are circles. But in future lessons, we'll be dealing with the circle. But we're going to leave that as pi, because anything else is an approximation. Right? So this just keeps on going on and on. 3.14. See if I remember the rest of it. I think it's 314. I don't even know the rest of the values. Was it 117, I think? And it just keeps on going on and on. But it's not important that you know all the values, because we're going to keep pi in terms of pi. So anytime we're dealing with pi, unless it's a real world problem, pretty much that's it. Unless it's a real world problem, or it's a problem you're solving for a benchmark or AZ Merit that asks you to change that to a decimal value, we're going to just keep it in terms of pi. And when we do change it to a decimal value, we'll multiply by pi, because your calculator should have pi on it. Right? That'll include more digits, and so we're not sitting there trying to think, okay, what are the digits of pi? Right? If I sat there, I could think about it, because I know that Pi Day was not that long ago. I think it was last March. Right? I think there was Pi Day, and it was special because it included so many digits of pi. And I think it was just this year. So if I stop and think about it, I could think about more of the digits, but it's not important because you can just keep things in terms of pi. So for circumference, we're just going to take our radius and multiply that by 2. 2 pi r is our circumference. That'll give us the value of the distance around the circle, and we'll keep that in terms of pi. The area is going to be pi r squared. All right, so some important notes. Note number 1, height is always blank to the base. I wonder if you know what it is. Well, little hint here is that little box. Height is always perpendicular to the base, which is why in the case of that triangle, it was not one of the sides of the triangle, because that was not a right triangle. Right? So unless you're dealing with the right triangle, when you go to find the area, it is not going to be 2 sides. It's going to be 1 side and a value that is perpendicular, a measurement that's perpendicular to that base. So the base here, this will be a side of the triangle. The height, however, is not necessarily a side of the triangle. It'll only be a side if it's a right triangle. Right? Otherwise, it's just going to be that perpendicular distance between the base and the opposite vertex. Right? And we'll go over that in more depth and more detail when we find some problems on the coordinate plane, some areas and perimeters. So perimeter and circumference is in linear units. Example, centimeter, meter, inch, foot, etc. Let's talk about area. So add this one to your notes. Area. Area is going to be in squared units. So instead, we're going to have, instead of meters, we'll have meters squared. Oh, that's centimeters there. Centimeters squared, inches squared, feet squared, and so forth. Right? So area is squared units, and perimeter, circumference are just linear units. It's just distance. Okay? All right, so let's do some problems together. Now that we've gone over some notes, and by the way, if I went too fast and you need me to slow down so you can write things down, you can just hit pause and you can write everything down. All right, and so now just kind of watch. We're going to solve some problems. If you feel you want to take some notes here, feel free to. I just didn't add these ones to the notes because they're not on the coordinate plane, but I did want to just kind of review through them just to practice a little bit with area and perimeter. All right, so to find the perimeter here, I just have to take 2 times the base and 2 times the height. Doesn't really matter whose base and height. I tend to call the horizontal one the base and the vertical one the height, but if you switched them, you'd still get the same answer. So our perimeter here is 2 times 5 plus 2 times 3, which is 10 plus 6, or 16 meters. The area would be 5, let me write the formula down too, since we're reviewing that. Base times height, so the area would be 5 times 3, or 15 meters squared. That's all there is to it. And it will do the same thing when it's on the coordinate plane. We just have to work just a little bit harder to find our measurements sometimes. All right, so here find the perimeter and the area. All right, so the perimeter, we're just going to add up the 3 sides of the triangle. So our perimeter is 9 plus 12 plus 12. And so here it'll be 24, this is a 9, not an A. 24, 12 plus 12 is 24, plus 9 is going to give us 33 yards. The area is 1/2 base times the height. Here they're nice enough to tell us that that's the height. And so the height is that perpendicular, that straight vertical or I shouldn't say vertical, that straight distance. So you're going, the fastest way, right, to the other side of the triangle. right, from your base to the opposite vertex. Right? So since we have a right angle here with this side, this 12 yards here is my base. That perpendicular measurement from the base to that opposite vertex, that's the height of this triangle. So the area is 1/2 12 times 8. Right? So 12 times 8 is going to give us 96. Half of 96 is 48. So this would be 48 yards squared. Now, that is not, I could find a height. I could have any one of these sides be the base, and then the height would be the line perpendicular from that side to the other vertex. But we'd have no way of finding that out in this triangle. Well, maybe we could find it out, but we'd have to do a lot of work. Right? Here we're given the height, so of course we're going to use that. When we're solving on the coordinate plane, we're not going to necessarily be given the height, but we're going to choose the value that makes the most sense for us to use. So long as it's that measurement is perpendicular to one of the sides of the triangle, then that side is the base, and that perpendicular measurement, that's the height. And I missed number 2 here. I was going vertical. So let's find the perimeter or circumference and the area. Right? So our circumference is 2 pi r. Our radius is 5. So our circumference would be 2 times pi times 5, which is 10 pi centimeters. Our area is pi r squared, so that would be pi times 5 squared, or 25 pi centimeters squared. Right? So we're going to just leave that in terms of pi. Right? Super easy. Right? So our perimeter, we'll just add up the 3 sides. So this would be 8, and it doesn't matter who's who, A, B, C. So we'd have 8 plus 10 plus 6, and so our perimeter is going to be 18 plus 6 is going to give us 24 yards. Okay. Now, one of these, 6 or 8, is the base, and 1 is the height. It doesn't matter who, right, because you're just multiplying them. This time, the base and height are sides of my triangle. I guess I shouldn't have called that one B, huh? Maybe I should call this one B, right? Because B for base, doesn't really matter. But this one here, I'm going to say is base, and this one is height. When we were finding the perimeter, I called this side A, and nope, I called this side A, this side B, and this side C. That is a terrible looking B. That's twice. B and the side C. All right, so it doesn't matter which side is A, B, and C. You're just adding them up. And on the right triangle, it doesn't matter who's the base and who's the height, but those are the 2 values you're going to use. So the only time you're using 2 sides is for a right triangle. Right? So right triangles only use 2 sides of the triangle, and they're never the hypotenuse, because the hypotenuse is opposite that right angle. Okay? So it's not meeting a side at a right angle. It's the 2 legs. And so the area here is 1/2 times 6 times 8. Half of 48 is 24 yards squared. And then let's do 5 and 6. Right, so 5 here. Find the area and circumference of the circle inscribed in the square. You might think, oh, maybe this is really difficult, but it's really not. This distance here, right, if this side is square, right? So if this side is 14, so what? So excuse me. Then guess what? Not so what, but guess what? All these sides are 14, right? So every single one of those is 14, including the diameter of my circle. Notice that from one point on my circle to the other, I go right straight across the square, right through the middle there. So this diameter here is also 14 yards. The radius is just 1/2 the diameter. So my radius is 1/2 of 14, or 7 yards. Right, so that means our circumference is 2 pi times 7. I won't write the formula again because I just wrote it by number 2. So that would give us 14 pi yards. And the area is pi times 7 squared, pi r squared. So that would be 49 pi yards squared. So that wasn't very difficult. As long as you realize that the radius is 14 and that the diameter is 14 and the radius is half the diameter, that's a pretty easy problem. All right, then this is our last one here. So the perimeter, we just add up the 3 sides. So that's going to be 15 plus 12 plus 6. My shadow's blocking. So that's going to give us 27 plus 6, 33 centimeters. All right, so this is my base. Just this here. Right? This is my height. You might think, how can that be? They don't even meet up. Well, that's not really important that they meet up because I could draw that same line and, well, everything's going to move with it. But I can move it over here and then it meets up. Right? It just looks a lot prettier over here, and it makes it clear that it's going straight. It's going the straight vertical distance here, the fastest distance, right, from where the base is to where the opposite vertex is. So that is the height of the triangle there. So our our area is going to be 1/2 times 6 times 10. And that would be 30 centimeters squared. Right? So that's the end of my little review here on area and perimeter. That took a little longer than I thought. But I'll be back with another podcast for this lesson. Right? Bye for now.